Good afternoon, everyone. So we'll just be taking a quick detour for a bit, and I feel like I'm sort of in a lion's den kind of situation, kind of presenting an alternative or to NATS, to Kafka in a room full of Kafka experts. But everything has a time and a place and an appropriate situation where it's applied. So also the title was a bit of clickbait, right? So take it with a bit of my intentions only to present an alternative piece of technology, or rather a piece of technology that I feel is not is sort of overlooked on, and that's the only intention of this talk. This is not going to be a NATS versus Kafka war, and it's basically 30 minutes. So the what we can cover in this short duration is going to be heavily limited. I was actually planning to do a live demo, but it's a bit tough to do it in 30 minutes. Okay. Cloud native, CNC-based technology. Yes, yes. Yeah. So in the interest of time, I'll keep the introduction quite short. So I work as sort of like a staff engineer slash technical architect at Iotify. I'm basically a generalist, so I'm not a data science or data engineer here as such. But I'm just here to present what we use, because IoTify is an IoT simulation platform, and we basically do scale testing of IoT backends. And so when we do scale testing at millions of devices, we sort of deal with problems of tens of millions. So this is basically the nervous system behind the whole operation that we are going on. So basically, what is NATS? So let's just say it's sort of like a Swiss Army knife. So in case you can't read it, it says I tried to file my nails, but in the process I accidentally fixed a small engine that was nearby, which is quite nice. So that's sort of what NATS is. Let's say it's sort of a multi-tool as such. Now there's a slight difference in between event streaming versus messaging. NATS was built primarily as a messaging platform. So essentially, its job is to get data from the source to the let's say action logic. So this has applications in a plethora of use cases. So web is what most of you are quite familiar with. Let's say your web applications, your e-commerce, all of that. In addition to that, when you have distributed systems, say fog computing, edge computing, that are taking precedence right now, you might have distributed clusters as well. So this has a supercluster model as well. NATS can have certain managed clusters. You can have leaf nodes. So say this sort of blends into the IoT case as well. So if you have say data providers on an edge use case, say on the factory floor, and then you have say a NAT server in the to aggregate traffic from the factory, and this sort of ensures eventual consistency with an upstream NAT server. So you can think of cases where Kafka sort of requires the data connection to be quite stable, right? So here, this eventual consistency, as well as your edge node or leaf node architecture, kind of helps bridge that gap, as in gives you options to sort of still have a distributed system that can work pretty well. On-prem deployments. So, for example, how many of you guys have sort of deployed a Kafka cluster on your own, or Kafka? Quite heavy, right? I think that's something that you can all the deployment itself runs inside a JVM that comes with its own overheads. The NATS binary itself is 15 megabytes, and it can run anywhere that Golang can compile. So you can run it on a Raspberry Pi. You can. So if you look at the minimum hardware requirements for a NATS client on the NATS website, they say the minimum hardware requirement is TLS support. So if your hardware can handle TLS, just for some context, Arduino boards like your basic microcontrollers can't. You need a bit more power for that. But that's it. That's the minimum qualifying factor to have NATS enabled. Multi-cloud, like I mentioned, if you have geography-specific distributed systems, you can have topic level filtering. So that's sort of what this is basically intended for. It's supposed to be like I mentioned, the central nervous system of a very high performance, high throughput distributed system. Mobile as well. So you later we'll see how this can sort of fit into, say, your WebSocket communication and everything. So what we'll take a look at over here is message-oriented middleware. So that's basically all of the stuff that we as engineers don't want to deal with. Let's say if you really don't want to deal with how your network losses are happening, how your say certain things in terms of how the throughput is. It's basically engineered to be latency as low as possible. So that certain assurances and abstractions and prioritizations have been made in the architecture of NATS as a platform. And in the, I think, 8 to 10 years of its existence, it has sort of been quite opinionated in terms of what it's trying to achieve, as in basically whether certain priorities in the sense that NATS core itself does not have persistence, so it can't basically do whatever you're dealing with in terms of replaying of data. All of that is not there as NATS core. So we'll come across the next layer of that, which essentially comes as abstractions of those and certain challenges that this addresses. So M2N communication. So this is basically where the the streaming architecture kind of plays. If you're dealing with, say, in an event-driven architecture, if you're dealing with, say, your client-server model, you might have it's a one-to-one thing, right? So if you deal with gRPC, or if you deal with, let's say, your standard REST or GraphQL, it's all like a one-to-one client-server model. But say in the microservices architecture, you will essentially have event producers, and then you will have several microservices to handle that. You'll have replicas of microservices. So similar to how you have consumer groups in Kafka, here there is something called queue groups. So you have shared subscriptions. There's also topic level hierarchy. So similar to, from my best understanding of Kafka, is you have single topics, right? Your entire topic is one single string. Whereas if you deal with anybody here familiar with MQTT? I know the audience is a bit diverse here. Okay, MQTT, great. So message queuing telemetry transport, right? So if you know about the hierarchy system in MQTT, it's slightly different. So NATS basically provides you such hierarchical topics that you can subscribe to in terms of wildcard subscriptions, and basically do load balancing and stuff in that regard as well. Performance as well, like I mentioned, it's mainly made for super high throughput and super low latency applications. So that all of that is talking about the NATS core. When you talk about NATS JetStream, the conversation is slightly different, and we'll sort of come across the differences between the two as well. Also, another thing is dynamic systems and adaptability. So, for example, Kafka sort of evolved from a log aggregation platform, right? So it sort of got its foothold as a platform that was designed to aggregate and collect logs, right? Similarly, here NATS sort of has evolved into this, fabric that's interconnecting microservices. All of your service discovery, all of that, this can sort of work as an efficient transport layer. In fact, there's the platform that we're using called Molecular.js inherently uses NATS as an underlying transport layer, and some of our procedural calls, you can see the latency in microseconds, like hundreds of microseconds, like sub-millisecond in some cases. So design patterns. What are the common design patterns that you come across in microservices? You have your request reply, you have publish, subscribe, and these queue groups that I mentioned. All of those are well supported in NATS. So request reply is when your client requests a particular resource from a server. That can be in terms of a function execution. It can be in terms of, say, inputting some data, getting an actionable output out of it. All of those things, right? Publish subscribe is slightly different. So publish subscribe, let's say, whatever your producer of your event sends a particular event to a centralized broker. Subscribers express interest in certain topics. So what is a subscription? It's basically expressing interest. Let's say I'm interested in a particular let's say real estate, or I'm looking for flats in one particular area, and I tell this one particular broker who operates in that area that I'm looking for flats. In case you come across anything there, let me know. So next time, let's say a house owner puts a listing, this broker sort of notifies me as a subscriber. Right? So that's your basic publish subscribe model. And the broker just will not just notify me. There might be other like 10 other people like me who is interested in the same information. The broker will actually notify all of those people. In case my phone was switched off and he couldn't get me there, he'll retry a bit later. That information will eventually get to me. Whereas in one-to-one, you require your client as well as your server to be online at the same time. And as well as deployment methods, as one person suggested here, it's cloud native. So all of the struggles of certain anecdotal struggles that I've heard of people trying to having trouble deploying Kafka on Kubernetes, NATS has basically like first-class support for Kubernetes. It's basically built to be cloud native. If you want to say get NATS up and running on a Kubernetes cluster, you have Helm charts to do that. It's a very straightforward Helm install. So that's the easiest way. But there's also deep integration with Kubernetes authorizations. So even Kubernetes has this cluster of clusters model, right, in some cases. So you can essentially have Kubernetes level authorizations and RBAC privileges to ensure that certain resources are protected when it comes to topic subscription and things like that. Another advantage is if you're a developer, for example, our dev stack, it's very easy to spin it up because NATS is also available as a Docker image. So let's say when we are working on a microservice, we have a Docker compose that essentially has all of the Docker images that build up the microservice, and NATS is the transport layer. So since you can run NATS within a Docker container, you can also have a small version of your entire microservice system right in your dev machine. You do not need to depend on an external provider, or you do not need to deal with any of the overhead that it comes with. So it's meant to be this light, fast, lean kind of platform, right? This is the subject-based messaging that I mentioned. This is one of the key distinguishing factors. So these are your wildcards. So say you have a distributed system. So instead of doing the filtering at client level, let's say at an application level, so instead of getting a message and then checking the topic string for a regex pattern, this you can handle at the subscription. You can handle that at the subscription level itself. So here, for example, let's so let's look at this particular thing. There's system.us.login.uid123.123, right? So there's a dot-based hierarchy that's established there. So say you have a geographically separated system. You can very easily have a wildcard subscription for US and then greater than. So all events in the US zone will be coming to that particular client. You can also have, say, within the US zone, you have a controller specifically for orders. You can have a wildcard subscription based on system.us.orders.star. This is very similar to how MQTT works here, /hash and those kind of wildcard subscriptions. You can also, so basically star is one level and the greater than is basically everything succeeding that. So if you want, say, everything in the US zone, you can just do the greater than sign. Otherwise, if you just need one particular logic level, you can do this star as well. So subject-based messaging is a very huge distinguishing factor. Now, NATS core versus NATS JetStream. Now, the NATS core, like I mentioned, this is the leanest, or rather the fastest, inherently messaging-centric platform. This is not really focused on streaming. This is focused on getting the data from the source to the receiver as fast as possible in the pub sub model or request reply or whatever that you want. So this is, like I mentioned, the 15 megabyte binary. You can very easily spin it up. All of your request reply and your queue groups all inherently stay within the NATS core functionality. The NATS JetStream basically introduces persistence. That's so in case, like I mentioned, my intention out of this talk is for all of you to go check out NATS. That's it. So when you check out NATS, one thing you'll come across is NATS streaming and NATS JetStream. NATS streaming was basically that their first attempt, which had certain limitations and sort of got archived. NATS JetStream is where your inherent persistence functionality all comes through. So basically, it introduces certain interesting concepts like pub/sub decoupling. Like I mentioned, in case when the broker calls and my phone is basically out of coverage area, or switched off, or out of battery, right? The delivery can happen later. So that there's a decoupling between your publisher and your subscriber, and there can also be that one-to-many architectures that you can bring in. Another important thing is QoS, quality of service. So you will have your at most once, at least once, and exactly once, right? So NATS core by default only has at most once. So there can be losses within the system. However, unlikely, it's still possible. NATS JetStream introduces at least once and also exactly once. There was a lot of nuanced discussion regarding how exactly once is implemented in Kafka related systems, but I'm sorry, Hoodie, but JetStream pretty much provides it. I'm not entirely sure how it works under the hood, but that kind of raised the curiosity for me to go and check out how they are doing this as well. Also, NATS is open source. You can go. It's maintained by a company called Synadia. And I think the creator is a former CTO of VMware, something like that. So yeah, it's been around for quite some time. And a couple of other interesting features of NATS as such is native support for MQTT and WebSockets. So like I mentioned, when you're dealing with IoT related systems, right? You have very heterogeneous protocols that are involved. So I guess in your transport layer itself, you might have, say, JSON, you might have Avro, you might have protobuf, all of those. Whereas at protocol level as well, MQTT is pretty much the de facto standard there. So since NATS 2.0, there is native support for MQTT according to the MQTT 3.1 standard. There's also WebSocket support. So it's quite easy if you want. You can use the same NAT server, do WebSocket subscriptions, and then get notified of your data. So in case you're having some kind of a monitoring use case in a front end, you can do WebSocket subscriptions to your NAT bus. Object and key value store as well. So in case you need some working data, I think one of the concerns that were raised were like differences between event streaming and data streaming, and sometimes just the event intimation alone causes certain round trip overheads. So in between, you can actually make use of NATS object stores as well as key value stores, where you can essentially store and retrieve data across distributed systems. So like I mentioned, when you have a heavily distributed architecture where all of the eventual consistency is handled by the NATS core itself. Accounts and multi-tenancy, like I mentioned, this is actually one feature that I came across while preparing for the talk. I was not aware of this directly, but so they have Synadia, for example, has this thing called a NATS global service. So you essentially do not need to self-host it or self-manage it. You can pretty much, they have this cluster of clusters approach. Now, when a lot of the data in enterprise, you have data silos because of privacy reasons and data partitions and stuff, right? So when you have accounts, it actually implements a very strict RBAC. So basically, there is not even any crosstalk between the tenants. It's actually very interesting for people to check out on their own. And leaf nodes are what I mentioned for edge deployments, like the factory floor example. So all of your sensor data, say, goes into one particular edge node. Say the edge node, suppose, lost connectivity in between. So usually what happens is your factory floors and stuff usually will the sensors will not have TCP level access. It will not have internet access. So you might have something like Zigbee or LoRa or some kind of protocol to get the data to your edge node, and that's what essentially syncs stuff to your cloud devices. So you can pretty much use a leaf node there to ensure that your system is partition tolerant in some capacity. So yeah, essentially, like I mentioned, the call to action out of this is go check out the system at nats.io. And like I mentioned, there's the overhead to get this thing running is very less. And you do not, just to check out the system, you don't even need to write code. There's a NATS CLI where you can try, publish, subscribe, all of that. It's quite very beginner friendly to do that. There's also the subscription methods and all of that is quite friendly and quite fast. I personally even wrote like a NATS to Prometheus bridge wherein you could actually ingest hundred thousands of messages into Loki, Grafana Loki, and basically the tooling around this whole platform is like quite friendly and it's very easy to get started as well. That's a quick summary. I just would like to spotlight two websites as well for you to get started. I think I'm actually on time. Interesting. So nats.io itself is the actual website. Might as well show that. Also. So yeah, the core things that they highlight here itself is adaptive edge systems, distributed systems, a single platform for streaming, key value object store, and PubSub. Focus towards microservices, works from multi-cloud to edge. So you can already imagine what kind of breadth they are sort of aspiring to cover. Right? And so that's the NATS website. From there, you can access the documentation. All of the topics that I mentioned are basically an abstracted view of this documentation. I think we'll have a very quick Q&A, I think another 5 minutes left. But essentially a lot of, they've gone into quite depth of how exactly it is architected. So if you want to get started with a PubSub system on here, you can, there's a very interesting how subject mapping exactly works, all of the nuances, token-based partitioning, and all of that works quite. All of that is documented quite well here. Another thing to spotlight here is NATS by example. So similar to Go by example, in case you guys work with Golang, there's a NATS by example wherein you can actually get very fast tutorials on how to get things up and running very fast. So unless JetStream is mentioned, they'll be talking about core NATS. So if you want sort of like feature parity or something along the lines of what people accomplish with Kafka, JetStream is what you need. So NATS core is sort of meant for messaging essentially, not exactly streaming. Yeah, so leaf node topologies, your key value stores, all of your integration. This is a very interesting website as well. So I think we have 5 minutes for Q&A. Yes, sir.
I mean, I understand this is not a Kafka versus NATS that will has to rightly pointed. But then I have tried to set up Kafka and support enough operational points, right?
Okay.
Yeah, operational pain points, right? And everybody talks about how great Kafka is. Nobody talks about the operational pain points they suffer and what are the best practices they do to ensure that those operational pain points are mitigated.
Right.
Yeah, but then, right, technical capabilities are one, right? That's as you said, we are architects, or we are actually trying to get to employee for employee, right? So get to NATS. Technical capabilities are one, but adoption is another.
Yeah.
Right? You really have to agree. NATS has been around for quite some time. It's a CNC of very blessed technology. Right? It's not just that particular piece, right? It's the entire ecosystem of evolution that matters to an individual, right? So they get end-to-end solution, right? For example, Spark, Flink, right? I think there are people from Spark who are going to do the keynote presentations, right?
Yeah.
All these things are Kafka compatible, right?
Yeah.
And NATS has to evolve quite some time before it's then automated, right? What do you think?
I agree entirely. I also think it's a different space than what people want to accomplish with NATS. So let's say in your heavily transactional systems and heavily user-driven analytics systems, yeah, that entire stack is quite fast, and as well as your let's say analytics and ML ops and stuff like that, right? Yeah, that stack is quite developer friendly as well. Your turnaround time from a feature to an implementation would be quite small, and the ecosystem compatibility and plugins would be quite convenient. From my personal understanding, I think NATS is a bit more tailored towards, say, high performance backends, or let's say possible alternatives to gRPC based systems, or server to server communication, or maybe even M2M communication to a certain degree. Something that we are using TypeScript that's here. Yeah. Oh, cool. Nice. MOLECULAR in terms of, oops, I think I got the spelling wrong. Yeah, LER. So in terms of dev tooling, if in case you want something, I mean, this is not related to analytics and pipeline, data pipelines. This is just a shout out for a framework that uses NATS as a transport layer. In case you want to get a microservice up and running very fast, this will essentially handle all of your service discovery, all of your replicas, ensuring. So it uses NATS queue groups under the hood. You can say, for example, a metric service that we do handles ingest of, say, 1 million metrics that keep coming quite rapidly. So you want to spin up 3 replicas. You want to ensure that the messages are distributed between the 3 replicas. All of that is sort of taken care of under the hood. If you actually want to see what's happening, you can do that wildcard subscription, like molecular and then greater than, and then you actually see all of the traffic that's happening. It's quite a very interesting thing. But yeah, thanks for the great question. I think the short answer is I think it's positioned slightly wrong.
So we use NATS.
Oh, great.
Yeah, I was going to ask you should actually ask. I'm just curious. How many use that?
How many? Yeah, actually, just for the interest, how many are actually NATS users? Okay, 2. Okay.
But yeah, I have a question.
Yeah.
I want to lend some support.
Sorry?
I wanted to first lend support saying I use NATS.
Okay, thank you.
So you have the IT use cases, right?
Yeah.
We have a similar use case
Mm-hmm.
where we tried JetStream.
Right.
JetStream is actually very new, so I couldn't find a lot of benchmarks.
Yeah.
So I am doing my own benchmarks.
Yeah.
What we found is, when you have a lot of consumers for a given stream,
Yeah.
and our consumers were R3 file replica.
Sorry?
So when you look at NATS JetStream, when it makes a stream and you as a consumer to it, on the consumer side, you can again say that you want to store the offsets and other metadata in file,
Right.
or in memory, stuff like that.
Right.
So the problem that we faced is when we have a lot of consumers, which you would probably have in an IoT use case, to a JetStream, then at one point when you start scaling the number of consumers to the same stream, it just gives up. Have you tried JetStream to have any numbers to share on the number of consumers that one?
So sticking to the terminology of producers and consumers, I think in an IoT system, consumers would be lesser, right? Producers would be more. Is that?
I'm not an IoT.
No, okay. No, I mean, I just wanted to understand your use case a bit more. Are you talking about like in an IoT use case, the people reads would be greater than writes, right?
But the question was like, if you have a lot of consumers,
okay,
and you have a persistent stream and a persistent consumer data system,
right?
Then JetStream is something that did not work for us.
Okay.
The other question I want to ask is because you talk about the producer.
Yeah.
We use something called Apache Pulsar. It's I think more similar to Kafka than NATS.
Yeah.
We use Pulsar as well as NATS.
Yeah.
So we are moving some stuff from Pulsar to NATS. At least we're planning that.
Yeah.
And while we do that, we look at producer throughput. So in a Pulsar or a Kafka kind of system, I would add partition topic and increase the number of partitions come to increase producer throughput.
Right.
Here, although you have subjects, something called subject mapping and stuff.
Yeah.
Like, you don't have a partition kind of a thing.
Oh, you mean like storage partitioning?
No, topic partitions.
Yeah, so topic partitions as in like distributing that over different computers, right? I think that's there in the feature backlog. I don't think it's implemented yet. I remember seeing that in the.
So, from the producer side, you have any benchmark that you have done good on JetStream only?
Yeah, so it was able to sort of handle our million scale load just fine. We had a bit of trouble querying stuff, but then it's not a persistent consumption. It's sort of like a large amount of data coming into JetStream, and then later we are sort of querying stuff out of it, similar to how a database would be. But yeah, that's primarily been our use case. But yeah, we've been sort of happy with how much throughput it could actually take.
Are you using JetStream very actively, or do you use core more?
We use core more sort of because we sort of had our own storage engine, and because of certain other startup related factors.
I think the core one works very beautifully.
Right.
I completely agree.
Yeah.
JetStream, you had a little bit trouble when we are waiting.
I think it has a bit more to mature as.
Yeah.
Yes.
We take one more question and then we take the rest.
You mentioned key values, so that key values should, is it like AWS IoT device shadow?
Sorry?
You mentioned key value store. Right?
Yeah.
So is that can replace AWS IoT device shadow?
No. I mean, that's slightly different entirely. So if you deal with the MQTT subscription, that will be similar to the like if you have the MQTT bridge along with NATS JetStream, that will be similar to AWS device shadow. AWS device shadow mimics the entire device state always. So unless you actively do that sort of like storage, it can't be a one-to-one for AWS device shadow.
Key value store can't compare.
No, there's also an object store, which is at the end of the day, it's basically text. But yeah, I don't think it's like directly a mapping of AWS device shadow.
Key value store, how this is entire store communicated to the other party, or like the other party can take only few keys?
No, that's entirely authorization as well as topic level mapping based.
So which database used for the key value storage, like Kafka is having like RockDB.
Yeah.
Which database they are using?
That's actually in memory internal.
Like in memory, like you have got like a mini database, like which.
I'm not exactly familiar with the underlying architecture of this. Again, this is sort of like an evangelism exercise.
And when you tell
I
about,
think we'll sync up offline if that's okay.
We take the rest of the questions offline. But thank you so much, Robin, for the